Okay, so for today, we are reviewing for the Chapter 12 test. First concept is the unit circle. That's where you'd have a whole bunch of points here, 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 and here, which are all easy to define as, 0, 1, 1, 0, 0, -1, etc. This spot right here, for instance, is 1, 0. And that means at that spot, I could do sine of 0 degrees. Sine of 0. Here's where 0 degrees is. It's an angle that never even opened. Okay, sine is y, and y is this part, and therefore the sine of 0 degrees would be 0. The cosine is the x. Cosine of the 0 would be 1. And tangent of, at this spot, tangent is TOA, opposite over adjacent, but wait a minute, there's no triangle. So you don't say tangent is opposite over adjacent in this case. If sine was y, cosine of the angle's x, what's tangent of the angle? Y over x. And therefore it's 0 over 1. Is that legal? 0 over 1. Is that legal? 0 on top is okay, and the answer is just 0 then. If I have 0 cookies divided amongst one person, they get 0. All right. So, final answer. What is this question I had posed earlier? What is the sine of 3 pi over 2? Well, here's where 3 pi over 2 is. How many of you knew we were talking about that spot? Okay, good. And that spot is what, comma, what? 0, -1. And if I want the sine of it, the sine is the y of it, and therefore it's -1. Okay, raise your hand if you had that one right. Okay, good. All right, on to the next one. In the back row. In the back row. Remove the hat. That might help you stay awake. You're too warm. All right. So we're going on to a circle, except this time it isn't going to be on one of those major lines. Those are called the quadrantals, by the way. No, you don't have to know that for the test, but you do need to know it. No, but it's something I'm referring to. These spots here where you can't make a triangle for that spot either. Those are quadrantals. But this is a spot you could make a triangle for, and it's pi over 4. Would you please draw the triangle that goes with pi over 4? And you know it. You know all the sides and all the angles. And the question would be, what is sine, cosine, and tangent of pi over 4? Now, some people are going to ask me, do I have to convert this to be on the unit circle? The answer is no. You don't have to, because you can get the answers without it being on the unit circle. In other words, the radius of this thing doesn't have to be 1. So it does help some people, but it doesn't always work the best that way or make it easiest. Do you get that this is a 45-degree angle? If you haven't memorized that pi over 4 is 45, how could you have gotten that? You got to think 180 is like pi, and therefore it's like 180 divided by 4. Well, that's like 180 divided by 2, and then divided by 2 again. So that's 180 divided by 2 is 90, divided by 2 again is 45. There we go. All right, so it's a 45-degree angle. Did you get that, therefore, this is 1, 1, and the square root of 2? Raise your hand if you had that right. Good. Do you get why if I wanted to make this thing into on the unit circle, I'd have to divide everything by square root of 2? Because then, now my radius just turned into 1. Okay? Do you have to go through that step? Nope. Because if I want the answer for sine of 45, do you get it would work just as well? Sine is opposite over hypotenuse. That over that is going to work just fine. You don't have to make it into the unit circle if you don't want to. If you wanted to know exactly what that point is on the unit circle, if they're forcing you to be on the unit circle, well, then you have to divide by 2 everywhere. Sorry, square root of 2. But either way, what's the sine of pi over 4? It's, sine is the y. It's the y distance. This is the y distance. So it's 1 over square root of 2. And that's over hypotenuse, which is 1. Right? Now you might be thinking, but what if I had left it as the green numbers? Before you put in those red square root of 2's, do you get it would have been 1 over square root of 2, it would still be the same answer. The sine of that angle is going to be the same, no matter what the sides are. Okay, so it's 1 over square root of 2 either way. What's the cosine of it? What did you get? Cosine pi over 4. Look at it. What do you think it is? You can do it either with the square root of 2's on the bottom or not. Okay, I'm going to ask you a different question. What is cosine of 45 degrees? Look, what's cosine in this triangle? Just look in the triangle. Cosine's adjacent over hypotenuse. Okay, what's the adjacent side here? That one. What's the hypotenuse? That one, which is equal to 1 if we're in the unit circle. Okay, so it is 1 over square root of 2 again. If we had just used the green sides, I know this is getting really messy. If I change these to just 1, 1 and the square root of 2, it might have actually been easier. So here's my triangle again. 1, 1, square root of 2. And it would have probably been easier to just go that over that. 1 over square root of 2. Raise your hand if you had that one right. Okay, and the last one, Mr. JL. Tangent. A little louder. It would be 1 because it would be opposite over adjacent, which is 1 over 1. Or you could be thinking in terms of the unit circle where this would have been 1 over square root of 2, 1 over square root of 2, and then you'd say the exact same thing over the top of itself equals 1. Either way, the answer is 1. Raise your hand if you had a 1 for that one. Okay, good. All right, we've gone through about a third of the things that you've been taught so far. All right, next thing. Make a new circle. Show me where 11 pi over 6 lives. And then name me something coterminal, as in shares the same exact spot on the circle. 11 pi over 6. Try to figure out where it is. And if it were me, I would think about where's 1 pi over 6? And then I'd count it up. Show it to the person next to you and see if they have the same spot for 11 pi over 6. You need to get with me or you're going out. Okay, good. Show it to him. He's trying to compare with you. Did he already show it to you? Yeah. All right. Okay. All right. So, here's 6 pi over 6 because 1 pi over 6 is right here. And you know that pi is here, which is the same as 6 pi over 6. So there's 6 pi over 6, 7, 8, 9, 10, 11 pi over 6 is all the way around to here. Raise your hand if you had that one right. Okay, good. Now, figure out what the tangent of it is. Tangent. To do that, you have to draw a little triangle like this, right? Do you get that that triangle does not have an 11 pi over 6 in it? 11 pi over 6 is this angle that goes around the outside. Like, that's 11 pi over 6. So this little angle that's left, how much is that right here? Pi over 6, also known as what? 30. Now that's called the reference angle. It's the angle that goes with it to finish it off. In other words, to make it go all the way to the next bar. All right, so how about this? It's the angle that's in the right triangle, and it's the angle that's closest to the center. We call it the central angle. Because there's only one angle that's really close to where the center of the circle is. Right? Okay, so that is called the reference angle. Do you get 11 pi over 6 is the angle And pi over 6 is the reference angle. Okay. You get the reference angles are always less than 90 because they will be part of right triangles and you'll never have the 90-degree angle right there. So reference angles are always nice little angles. They're usually ones you're familiar with, like 30, 60, 45s. Okay, in this case, it's a 30-degree angle. That makes this a 30, 60, 90 triangle. If this is the 30-degree angle, then across from the 30 is a 1. That's something I would memorize on the whole 30, 60, 90 triangle. Because across from the 30 is where 1 is. And that helps you draw the rest of them. If that's 1, then this one's double that. It's 2. And this one's square root of 3. 1, 2, and the square root of 3. Now, I never said anything about this having to be on the unit circle, did I? So you don't have to divide everything by 2 right now. You could. But if I just ask you for, what did I say, sine, cosine, or tangent? Tangent. Tangent of 11 pi over 6, then I just need TOA, opposite over adjacent, this one over this one, and it's simpler to just say it's 1 over root 3. Could I have divided them both by 2 and done it? Oh, there's a negative. Oh, so easy to forget. This one's negative. There we go. Could I have divided them both by 2 and make all these numbers work for the unit circle? Yes. But then do you get, I would have just had a divided by 2 here and a divided by 2 here, which would have then flipped and canceled, and then it'd still be 1 over root 3. Negative. 1 over root 3. Okay. All right. So, there we go. That's the medium hard kind of problems. So what are the hardest things that you have to know for tomorrow? The hardest things are where there's 2 answers for them. And let's just talk about this briefly. What if I said sine of some angle is 1/2? Did you memorize this one already? What's that angle? 30. Sine of 30. So get how the answer is an angle in this case? Do you get how there's actually 2 angles in the unit circle that would work? I'd like you to draw me the picture for both of them. There's 2 angles that would work, and 30 degrees is one of the answers, also known as pi over 6. Draw the 2 triangles that would work for this, and I'll give you a hint. When I said sine of theta is 1/2, I should have really said sine of theta is positive 1/2. And as soon as I said sine of theta is positive, it gives me 2 answers. 2 places in this circle where sine's positive. It's very subtle, but it's, do you get that this 1/2 is positive? And as soon as they tell you that sine's positive, all students take calc. Sine's positive here and here. All of them are positive here. Sine's positive here. So it can't be there and it can't be there, but it could be here and it could be there. Raise your hand if you had those 2 triangles. Okay, good. Next, what are the answers? Not in degrees, but in radians. Don't say them. Tell them the kid sitting next to you. And you might be thinking, aren't they both 30s, Mr. Server? That's a 30, and that's a 30. Or if you want to use radians, pi over 6 and pi over 6. But this one, a reference angle is pi over 6. The actual angle is something else. All right. Show the kid next to you what you think the 2 answers are for this one. Okay. This one we can all agree was pi over 6. So what's this one? Well, it's not 6 pi over 6. That would be all the way, right? It's 1 pi over 6 less than that, because that's pi over 6. But this angle here is 5 pi over 6. Raise your hand if you had those 2 answers. Okay, good. There's another kind. This kind, you knew it was a common ratio for the 30, 60, 90 triangle. Do you get what I'm saying? You know the 30, 60, 90, you know the 44, 45, 90. Those are the ones that come up most of the time. But what if this had been a 1/3? A sine is opposite over hypotenuse, right? So the opposite side's 1 and the hypotenuse is 3. Yes, that could actually happen in an actual triangle. It's just that it's not going to be in a 30, 60, 90. And it's not going to be in a 45, 45, 90. And can you figure out the angle? Actually, no, you can't. But they won't ask you for the angle. They'll ask you to draw the pictures that go with it and then tell what like cosine of the angle is. We don't need to know the angle. We just need to know what the triangles look like, and therefore what the side ratios are. All right, this one's definitely trickier. Sine of theta is 1/3. What's cosine of theta? Strongly encourage you to draw the circle and then draw the two triangles. That would work for this. You know what? I'm going to narrow it down even further. I'm going to tell you that I want this to be in quadrant 2. In quadrant 2, comma, sine of theta is 1/3. Do you get how that'll narrow it down to only one triangle? Because normally there's two places where sine is positive. But this will narrow it down to only one. If you've forgotten your quadrants, you have to know this for the test. But this is quadrant 1, 2, 3, and 4. Okay, draw the picture, label the picture, figure out what is cosine of that angle. I'll pause while you give that a shot. So we got the triangle started here because we had to be in quadrant 2. And now what did you do? The hypotenuse is 3. Is 1. Shouldn't that be -1 over there? No. But it's important to remember that the other side is negative. How many remembered that this side that you found was negative? Ooh. Some of you may have forgotten it. It's so easy to forget. You saw me forget it earlier this hour. Okay, so what'd you do next? Nice. Square root of 9 for this one squared, and this one squared is 1. 9 minus 1, square root of 8. Good. So that one's a square root of 8. But it's negative. And so then, what's cosine of that angle? This angle right here, cosine of that angle. Cosine's adjacent over hypotenuse, so negative square root of 8 over 3. Yes, it's great if you made square root of 8 into root 2, or 2 root 2. Yes. Gentlemen, if you could turn around, please, that'd be good. Yes? Do you have to do what? Simplify the square root of 8? Yes, you should officially. Would I mark a whole R3 wrong because of that? No, but you might lose like a few percent. Yes? This is the right answer, except it isn't simplified, and there is a standard. What I usually do is a 5% doc for not simplifying. Yes.
Well, like for example, if you had a 2 underneath the 8 and a 3, then it would simplify down to just.
I get what you're saying, but either way, they still have the same issue. Is this right or is it not? Well, it's right, but it's just not simplified all the way. This is better, and I could not mark it wrong at all. And yes, if this had been like an 8 on the bottom, then it would simplify even further. But again, one thing at a time. This is a right answer. It's just not quite simplified all the way. It'd be great if you had put that as 2 root 2. Okay, let's move on. That was one where I narrowed it down to just one quadrant. Okay, and you didn't know the sides. That's one of the tougher ones. All right, here's another type of problem that we haven't talked about in a while, rotational motion. So if I have somebody who is riding their bike, and they're riding their bike, and they count the rotations because there's this, like, you know how people can put a spoke or a card in their spokes, and it would go tick, 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 tick as it goes around? Okay, so would the ticking noise be faster if the spoke, if it was at the, like, out by the edge of the tire versus the little card that you stick in there, the playing card? Here's your wheel. And here's the spokes on the wheel, right? And if you stick the playing card here, and it goes around and goes tick, 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 as opposed to putting it in here, would the ticking noise be faster? Agreed. If I have it in here, it has to go around once, one rotation, whether it's out here or in there, either way, it would tick at the same rate. That means the rotations per minute of this wheel don't care about where that card is. But how about this? If you have a bigger wheel, in what will run rotation get you farther? So if there was, this is my wheel again of my bike, and I got like some gum stuck to the bottom of my wheel, okay? And it goes around and hits the pavement. Every time it hits the pavement, you hear a little bit of a different like smack as it hits the pavement, okay? Do you get that if it's a little tiny wheel, like a trike, and there was a piece of gum stuck to that, and there's a piece of gum stuck to the big one, that the big one will travel farther every time the gum smacks the pavement? It will have gone farther. All right. Okay, so here's my question. That little piece of gum that's stuck to the bottom of that tire. If the rotations per minute, RPMs, on this tire is going, it's going around 400 rotations per minute. How fast is the person traveling? In miles per hour. Okay. So circumference is pi times the diameter, right? Could you still give me the answer without me telling you the diameter of the wheel? Oh, yes, you could. You're in honors pre-calc. Say it again. With a variable in it. Not that hard. You just carry that variable through your equation. I will tell you that the variable will be in feet, just to keep your life simple. The diameter is however many feet this is. Just to sum it up for you, it's going 400 RPMs. The question is, how fast is it going? And I didn't tell you the diameters, but you could still answer the question. Because a lot of times in this class, we make things in terms of a variable to make it more complicated. Yes, sir. Yes, the starts in rotations per minute, and we want you to change it to miles per hour. Multiplied by a whole bunch of things. And I know some of you want to grab a calculator. Don't. You can leave your answer in terms of D and simplify it as much as you can. But if you have to leave it as 20 pi divided by 5,280 D, then that's fine. Yes, sir. 5,280. But that's something you have to know, by the way. You don't have it memorized? You get it wrong. All right. Pause while you finish that off. Let's see what you came up with. Hopefully you knew it was, did I start with 400? Starts with that, and then you multiply by a whole bunch of factors, and then at the end, I want it to be in miles per hour. All right, so to get us closer to miles per hour, who can give me something I could multiply by? That'll just get us one step closer. Yes, ma'am. 60 min, notice me putting that on top because then this will cancel this, is 1 hour. Awesome, now I'm in rotations per hour. Who's got something that could cancel rotations? Yes? One rotation is pi times d. Awesome. And now it's do, and that's d. Oh wait, d has to be in what then? Feet. D feet. All right, d feet. All right, so 400 times 60, 6 times 4 is 24. Now I add up all the zeros. 24,000 pi d all over 1 times 1 is 1. And, oh, wait a minute. I'm in feet per hour right now. I'm getting close. I have to undo that. Wait, actually, I can leave them there because I'll just have to add in one more factor. What other factor do I still need? Okay, so I put miles where? Only reason I know it's on the top because see how it says miles on top over there? Okay, so then what's the fact I know about miles? 1 mile is, and now feet will cancel feet, and now it's in miles per hour. Sweet. And on the bottom I have 1 times 1 times 5280. 5280 goes here, and there's my answer. Could I do some canceling? I suppose, but I understand you don't have a calculator and therefore you aren't going to be able to necessarily finish that. But with the calculator, it'd be easy. Multiply, cut, stop, divide by what's on the bottom. Yes? Sure, go ahead. Grab your calculator and divide and see if your answer is the same. But all right, any other questions? All right, I've covered almost everything that you would need to know. All right, so I have made this review sheet to help you, and I want you to try this. Oh, wait, there's one more kind of problem, and that's where you get, I haven't done any where you, did I do one where you get 2 answers? Okay, all right, good, kind. Oh, I know, sectors. Same bike tire, a little sector of it. This is the tire part right here, right? Okay, my question is, if it's a 30-degree angle and this part of the bike tire right here is 1 foot, what, I go ahead and dot my 1 foot, my question is, well, what's the other thing you could figure out? The radius of the tire. Okay, figure out the radius of the tire, and then would you please figure out the area of the sector that would be made by the spokes and, like, in other words, that shaded region right there. Okay, so find both the radius and the area of that sector. I'll pause for a second and give that a shot. So by now I'm thinking everybody's at least either done or they don't know how to do it. It's one or the other because they're not that hard. All right, with me, gentlemen? All right. Okay, I don't know. I'd find it quickly, please. Whoever's. All right, so this one is S equals theta R. And theta, I don't know. It's got to be in radians. Did you know that? Because if you do S equals 30 times the radius, it's not going to work. But either way, I don't even know the radius right now. How am I going to figure this out? Well, I can find the radius by putting in everything that I know. What is S? 1. What is theta? Not 30. Pi over 6. Good. And then times the radius, I don't know. I put an R. Well, then I just have to get the R alone. So I'm going to flip and multiply, and therefore the radius in this case, a little weird, it's 6 over pi. Raise your hand if you had that one right. Good. And that's not that weird in that pi is just a number. Pi is 3.14. So it's like 6 divided by 3, so the radius is about 2. Does that seem okay in this scenario? Yeah, seems reasonable. Okay, so then here's my question. How do I figure out the area of a sector of a circle? I think a lot of you had forgotten this one. It's either in radians or degrees, there's a fraction of the circle that you have. And then it's the circle, pi r squared. In this case, what is our r? Pi is 6 over pi squared. You with me so far? And then the fraction is what part of the circle we have. Would you agree that this wedge here is 30 out of 360 is your fraction of the circle that we have shaded? 30 out of our 360 degrees. Now, could you have done that in radians? Absolutely. You would have said pi over 6 over 2 pi as your fraction. Which one's nicer? 30 over 360 is a lot easier in this case because we know the angles and the zeros will even cancel, so it's 3 over 6, 36, and then that even simplifies to 1/12. This one could simplify to 1/12 too, though, couldn't it? Yeah, it really would. Let me show you. Oh, and we still have to go pi times the radius squared. So then this part simplifies to 1/12. Let me prove it. Pi over 6 divided by 2 pi is the same as multiplied by 1 over 2 pi. You get how that also makes 1/12? So either way, it's 1/12 of the circle is how much we have to shade in. The circle itself is this part. I'm going to make that pi times 6 squared is 36 over pi squared, which is pi times pi, right? Can't one of those pi's cancel? Yes, it can. So then this part's 1/12. I showed you that before. This part's really 36 over pi. And then the 12 and the 36. 36 is 12 times 3, right? Cancel the 12s. The answer is 3 over pi. 3 over pi. Now, I wouldn't have expected you to be quite as good as me at simplifying that, but if your answer would have reduced to, you probably said 1/12 of all that. That's what I'm guessing a lot of you said. Raise your hand if you got that far. All right, then I should probably do another circle with area deal. So let's say I just want to know the area. This is 5, and this is pi over 4. Would you figure out the area of this wedge of the circle then, the sector? If this is 5, let's make it inches just to have a unit. I'll pause while you give that a shot. Okay, to finish off this last problem. Okay, so what we need to do is area of the sector is, there's a formula for that. If we do it in degrees, it would be however many degrees it is out of 360 degrees. Then you times by pi r squared for the circle. But what if it's not in degrees like this one? What if it's in radians? Well, you could change the radians to degrees or change the 360. What's that like in radians? 2 pi. I'd like you to try it this way if you haven't already. Pi over 4 in this case, our central angle, over 2 pi. And then pi r squared, and our radius in this case is 5. And therefore 5 squared. Simplify that down as much as you can. Like, you know what 5 squared is. You know that this is going to simplify to a fraction. And you'll have an answer like 36 pi over 10 or something like that, although that would simplify further. Let's say it was 36 pi over 11. There'll be some answer like that when you're done. So hopefully you have simplified this part to pi over 4, and instead of divided by 2 pi, times by 1 over 2 pi. That's why we practiced that on the top 20. So then that cancels that, and this becomes 1 over 8. 4 times 2 is 8. 1/8 times pi times 5 squared is 25. Would you agree that's 25 pi over 8? Raise your hand if you had 25 pi over 8. Okay, good. Any questions on that one? Does anybody want to see another, and it would have to be more than one, but anybody want to see another one like that? Because you'd like to see more practice on that. All right, I've got several. All right, we'll do another quick one. This one I'll do in degrees because that'll shake it up a little bit. Let's say this is 60 degrees. And let's say this is 8. I would like to know 2 things. How long is this little sector of the circle right there? And then what's the area of the red shaded sector? The first is, what's the arc length? The little red, sorry, the blue arc length. And then what's the red shaded area of the sector? I'll pause while you give that one a shot. Okay, first for the blue part. Mr. S, what do you think? No, not that Mr. S, the one behind you. Go ahead. What is S? We don't know. What's theta? But in case you don't know this, that has to be in radians. Pi over 3 is correct. Good. Times the radius. And so therefore your sector is 8 pi over 3. It's not sector, sorry. That's the arc length, that blue arc length. And S is a terrible letter for this because it makes me think sector. And it should, in my opinion, this formula should be AOR, arc length, instead of S. But anyway, S is the arc length. Raise your hand if you add 8 pi over 3. Okay, good. Then the other part is the area of it. The area of the sector is, it's either in degrees, this could be 30 degrees, no, sorry, 60 degrees over 360. Or if you wanted to do it in radians, 360 becomes 2 pi. And 60 would be how many radians? It would be pi over 3. And then either way, though, it's times pi r squared. And the radius here is 8, so pi times 8 squared. So I'm going to do it with radians just to show you the tougher way. Times by 1 over, instead of divide by 2 pi, it's times by 1 over 2 pi. And those pi's cancel, and this becomes 1/6 times pi times 64. So it's 64 pi over 6. Can that be factored? If you can factor, you should. The 64 can break up into a 2 times 32 times pi over the 6 is a 2 times a 3. 2's cancel. 32 pi over 3. Unless 3 goes into 32. I don't think it does. Okay. And if you didn't reduce that all the way, shame on you. You might have lost 5% for not being able to reduce. Sir.
You're finding the length of the sector. You have to convert it from degrees.
Just to clarify, I keep saying it wrong, but you just said it wrong too. That blue thing is, that's a length, but it's the length of the arc. Okay, now say your question again.
Do you have to convert from degrees to radians?
Okay, question. If this 8 was in inches, do you get how I'd have an 8 inches right there? Do you get how the answer is automatically in inches? Because radians don't have units. You get how that doesn't have inches, feet, miles, radians in it? It's actually a pure number. That way, when you take this pure number and you times it by 8 inches, the answer is in inches. And if it's a length, then it's just inches. If it was over here in this formula, same thing applies. That doesn't have units. That way, when this is in inches, the answer is just inches squared. So radians don't have units. So you don't change it to radians. Radians don't have units. So when the radians get multiplied here by this, the answer is just in inches.
So you couldn't put 60 right?
Okay, just to clarify, are you trying to put it back to degrees? Because could you put a 60 right there? No. This formula only works for radians.
Oh, okay.
It's a totally different thing, too. Think about it. If the answer was 60 degrees times 8 inches, that's not actually a thing. That's inch degrees. Well, it makes no sense. Okay? So, no, you cannot use degrees. It will not work. You have to change them to radians. All right. So, we kind of started with the last kind of questions that we had learned. No, actually, I'm sorry. We started with something we learned a long time ago, okay? And this is the very end of a video that covers everything, okay? So now, people that have watched this whole video, you are pretty well prepared for that test on Chapter 12 that's coming tomorrow.